Kotlin is a modern language for the JVM, created by JetBrains to be better than Java while staying fully compatible. You can use Java and Kotlin together in the same project, making it easy to modernize code bases without a full rewrite. Kotlin's concise syntax means less code, fewer bugs, and easier maintenance. Google's endorsement of Kotlin as the preferred language for Android development accelerated its adoption. Today, most professional Android developers use Kotlin, but it's also popular for server-side, web, and even native apps. Its multi-platform capabilities let you share code across Android, iOS, and more. Backed by JetBrains and Google and supported by a vibrant community, Kotlin is here to stay. In this guide, we'll explore the features that make Kotlin a joy to use. Setting up Kotlin is simple, especially if you're familiar with Java tools. JetBrains' IntelliJ IDEA, with built-in Kotlin support, is the top choice for most developers. Android Studio, based on IntelliJ, also offers seamless Kotlin integration for mobile projects. For Java projects, the IDE can convert Java files to Kotlin automatically, easing migration. Plugins for other editors like VS Code and Eclipse are available, though less integrated. You can also use the Kotlin command line compiler for scripts or custom builds. Gradle and Maven are the standard build tools, both supporting Kotlin out of the box. With these tools, you'll be ready to start building Kotlin apps in minutes. For Java developers venturing into new territories, Kotlin offers a welcoming landscape. Its syntax, while distinct, carries a comforting familiarity, easing the transition and minimizing the initial learning curve. You'll find that many of the core concepts you're already familiar with translate seamlessly, but it's much cleaner. Kotlin streamlines many aspects of Java, reducing boilerplate and verbosity. This results in code that is not only easier to read, but also faster to write and maintain. The clarity it brings can significantly improve your development workflow. Variables use val for immutable. This encourages a more functional programming style, where data is treated as constant whenever possible. Immutability helps prevent unexpected side effects and makes your code more predictable and easier to reason about. And var for mutable. While Kotlin embraces immutability, it also provides the flexibility to use mutable variables when necessary. This allows you to choose the right approach for each situation, balancing safety with practicality, with type inference reducing clutter. Kotlin's smart compiler can often deduce the type of a variable based on its initial value, eliminating the need for explicit type annotations. This makes your code cleaner and more concise, without sacrificing type safety. Function declarations start with fun. This simple keyword signals the beginning of a function definition, making it easy to identify functions within your code. It's a small detail that contributes to Kotlin's overall readability, and return types come after the parameter list. This might seem like a minor change, but it improves readability by clearly separating the function's input from its output. It also aligns well with Kotlin's type inference capabilities. Semicolons are optional. This seemingly small detail has a surprisingly large impact on code cleanliness. By removing the need for semicolons, Kotlin reduces visual clutter and allows you to focus on the logic of your code, so code looks less cluttered. The absence of unnecessary syntax elements like semicolons contributes to a cleaner and more readable code base. This makes it easier to understand and maintain your code, especially in large projects. Kotlin replaces Java's ternary operator with if expressions. This change promotes readability by using a more explicit and familiar construct for conditional logic. The if expression can also return values, making it a versatile tool, making conditional logic more readable. By using if expressions instead of the ternary operator, Kotlin makes it easier to understand the flow of your code. This is especially important in complex conditional statements. The when expression is a powerful upgrade over Java's switch. It offers more flexibility and expressiveness, allowing you to handle a wider range of conditions with ease. The when expression is a key feature that simplifies complex control flow, handling any type and returning values. Unlike Java's switch, Kotlin's when expression can handle different data types in each case. It can also return a value, making it a more versatile and powerful tool for conditional logic. For example, when can check ranges, types. This allows you to write more concise and expressive code for handling different scenarios. The ability to check ranges and types directly within the when expression eliminates the need for verbose if-else chains, or custom conditions. You can define custom conditions using Boolean expressions, giving you complete control over the logic of your when expression. This makes it a powerful tool for handling complex scenarios, reducing if-else chains. The when expression simplifies complex conditional logic, making your code easier to read and maintain. By replacing long chains of if-else statements with a single when expression, you can significantly improve the clarity of your code. Null safety is built in. Kotlin's type system distinguishes between nullable and non-nullable types, preventing null pointer exceptions at runtime. This is a major advantage over Java, where null pointer exceptions are a common source of errors. So you avoid many common runtime errors. By enforcing null safety at compile time, Kotlin helps you catch potential errors before they make it into production. This can save you a lot of time and effort in debugging. Extension functions let you add new methods. This powerful feature allows you to extend the functionality of existing classes without modifying their source code. Extension functions are a great way to add utility methods to classes you don't own, to existing classes without inheritance. This avoids the complexities and potential drawbacks of inheritance, providing a cleaner and more flexible way to extend functionality. You can add methods to classes from external libraries or even the standard library. Lambdas and higher-order functions. These features enable you to write more concise and expressive code, especially when working with collections. Lambdas are anonymous functions that can be passed as arguments to other functions. Make collection processing concise and expressive. Kotlin's standard library provides a rich set of functions for working with collections, and Lambdas make it easy to customize these functions to your specific needs. This leads to more readable and maintainable code. Coroutines simplify asynchronous programming. They provide a way to write asynchronous code in a sequential style, making it easier to reason about and debug. Coroutines are a lightweight alternative to threads, making them more efficient for handling concurrent tasks, letting you write sequential-looking code that's non-blocking. This makes it easier to write responsive and efficient applications, especially when dealing with I/O operations or other long-running tasks. Coroutines allow you to write asynchronous code without the complexity of callbacks or promises. Migrating from Java to Kotlin is straightforward. Kotlin is designed to be interoperable with Java, so you can gradually migrate your codebase one file at a time. You can even use Java and Kotlin code in the same project, and you'll quickly appreciate the productivity boost. Kotlin's concise syntax, powerful features, and improved tooling can significantly speed up your development process. You'll be able to write more code in less time with fewer errors. The language is designed to solve real-world problems. Kotlin was created to address the shortcomings of Java and provide a more modern and practical language for building applications. It's a language that's both powerful and easy to use. Java developers face every day. From null pointer exceptions to verbose syntax, Java has its share of challenges. Kotlin addresses these challenges head-on, providing a more enjoyable and productive development experience. With Kotlin, you write less code and get more done. Its modern features and concise syntax allow you to focus on the logic of your application, rather than the boilerplate. This leads to faster development cycles and higher quality code. Kotlin tackles null safety head-on, offering a robust solution to one of the most common pitfalls in software development. It's a proactive approach designed to catch potential errors before they can cause havoc in your applications. Aiming to eliminate null pointer exceptions, those dreaded runtime errors that can bring your application to a screeching halt. These exceptions often occur unexpectedly, making debugging a frustrating and time-consuming process. By default, variables can't be null. This is a fundamental aspect of Kotlin's design. It means that you must explicitly declare when a variable is allowed to hold a null value, promoting safer coding practices from the outset, unless you explicitly declare them as nullable with a question mark. This clear distinction between nullable and non-nullable types is key to preventing unexpected null pointer exceptions. It forces developers to consider the possibility of null values and handle them appropriately. The compiler enforces null checks, acting as a vigilant guardian of your code. It analyzes your code for potential null pointer exceptions and flags them as errors during the compilation process, catching issues at compile time instead of runtime. This early detection is a game changer, as it allows you to fix errors before they make their way into production, saving you time, money, and potential headaches. To safely access nullable variables, Kotlin provides a set of powerful tools and operators. These features allow you to interact with nullable values without the risk of triggering a null pointer exception. Use the safeCall operator, which only evaluates if the value isn't null. This operator is a concise and elegant way to avoid null pointer exceptions when accessing properties or methods of nullable objects. The Elvis operator lets you provide a default value if something is null. It's a convenient way to handle null values gracefully, ensuring that your code continues to function as expected even when encountering unexpected nulls. For example, name $.length, 0 returns the length or 0 if name is null. This simple expression demonstrates the power and conciseness of the Elvis operator in handling null values. If you're certain a value isn't null, you can use the not null assertion operator. This operator tells the compiler that you are confident that the value is not null, and it will proceed without performing a null check. But this should be rare. Using the operator bypasses Kotlin's null safety features, and if you're wrong, your application will throw a null pointer exception at runtime. These features make your code safer and more predictable, reducing the likelihood of unexpected crashes, and improving the overall reliability of your applications. Null safety is a core reason many developers switch to Kotlin, seeking a more robust and reliable programming experience. It's a key differentiator that sets Kotlin apart from other languages. It encourages better API design and fewer runtime crashes, leading to more stable and maintainable applications. By embracing null safety, you can build APIs that are less prone to errors and easier to use. Embracing null safety leads to more robust applications, providing a solid foundation for building reliable and scalable software systems. It's an investment in the long-term health and stability of your code base. In Java, simple data classes require lots of boilerplate: constructors, getters, setters, equals, hash code, and toString. Kotlin's data classes solve this with a single-line data class user: val name string, val age int. The compiler generates all the standard methods for you, making code concise and readable. Data classes also provide destructuring and a handy copy method for immutability. For example, user.copy, age =31, creates a new instance with a different age. This encourages immutable data and functional programming practices. Data classes are perfect for value objects and models. You get all the functionality you need without the clutter. It's one of Kotlin's most beloved features for reducing repetitive code. Extension functions let you add new methods to existing classes without inheritance or modifying the original code. For example, you can add isValidEmail directly to the string class. The syntax is simple: funString.isValidEmail, Boolean. Once defined, you call it like a regular method email.isValidEmail. Extension functions make code more fluent and expressive, reducing the need for static utility classes. They're resolved at compile time and don't actually change the class. This feature helps you create domain-specific APIs and cleaner code bases. Extension functions are a favorite tool for experienced Kotlin developers. Kotlin embraces functional programming with first-class support for Lambdas and higher-order functions. Lambdas are anonymous functions you can pass around as values. The syntax is clean at xy losum, x plus y. Higher-order functions take or return other functions, making code more flexible. The standard library offers functions like filter, map, and foreach for concise collection processing. For example, numbers.filter, it %2 =$, 0 but map it. You can place lambdas outside parentheses for even cleaner syntax. This approach makes your code more declarative and easier to read. Functional patterns are natural and powerful in Kotlin. Coroutines are Kotlin's answer to easy, efficient, asynchronous programming. They let you write code that looks sequential but runs without blocking threads. Coroutines are lightweight. Thousands can run on a single thread. Use the suspend keyword to mark functions that can pause and resume. Builders like launch and async start coroutines within a coroutine scope. Async returns a deferred, which you can await for results without blocking. Coroutines eliminate callback hell and make async code readable. For example, launch, val user =, fetch user, show user reads top to bottom. Structured concurrency ensures safe, manageable async operations. Coroutines are a game changer for modern Kotlin apps. Transitioning to Kotlin can be a really smooth experience, especially if you're coming from Java. The language was designed with Java interoperability in mind, making the move less daunting than you might think. It's all about taking the right steps and adopting a strategic approach. The key is to take it step by step. Don't try to rewrite your entire application overnight. Instead, focus on smaller, manageable chunks. This allows you to learn the language gradually and integrate it into your existing codebase without causing major disruptions. Start by adding Kotlin files to existing Java projects. Kotlin and Java can coexist peacefully in the same project, allowing you to introduce Kotlin incrementally. This is a great way to experiment with the language and see how it works with your existing code. There's no need for a full rewrite. Identify areas of your code that could benefit from Kotlin's features, such as data classes or extension functions, and start there. This targeted approach minimizes risk and allows you to see the benefits of Kotlin firsthand. Use data classes. They're a fantastic way to simplify your data models and reduce boilerplate code. Kotlin's data classes automatically generate methods like, and saving you a lot of time and effort. Write new tests in Kotlin to get comfortable with the syntax and testing frameworks. Testing is a great way to learn a new language, and Kotlin's concise syntax makes writing tests a breeze. Plus, you'll be ensuring the quality of your code as you go. Take advantage of IntelliJ's Java to Kotlin converter. It can automatically convert Java code to Kotlin, giving you a head start in the migration process. However, remember that the converted code may not always be perfectly idiomatic. Always refactor for idiomatic Kotlin. The converter is a great tool, but it's important to review the converted code and refactor it to take full advantage of Kotlin's features and best practices. This will result in cleaner, more maintainable code. Embrace null safety. Kotlin's null safety features help you avoid null pointer exceptions, a common source of errors in Java. Use safe call operators and the Elvis operator to handle nullable values gracefully. Prefer for immutability. Immutability makes your code easier to reason about and less prone to errors. Use to declare variables that should not be reassigned after initialization. Avoid overusing nullable types or the operator. While null safety is important, excessive use of nullable types can make your code more complex. The operator should be used sparingly, as it can lead to null pointer exceptions if the value is null. Design APIs to minimize nulls. Think carefully about which values should be nullable and which should not. Aim to create APIs that are as null-safe as possible, reducing the need for null checks in client code. Learn from the Kotlin community. There's a vibrant and helpful Kotlin community out there, ready to answer your questions and share their knowledge. Read the official docs, follow the blog, and stay up to date with the latest Kotlin news and best practices. The official documentation is a great resource for learning the language, and the Kotlin blog provides valuable insights and tips. Explore open-source projects to see how other developers are using Kotlin in real-world applications. This is a great way to learn new techniques and discover best practices. Focus on understanding idiomatic patterns, not just syntax. Kotlin has its own unique style and conventions. Learning to write idiomatic Kotlin code will make your code more readable, maintainable, and efficient. Use extension functions to add new functionality to existing classes without modifying their source code. This is a powerful feature that can help you write more concise and expressive code. Master expressions for writing concise and readable conditional logic. The expression is a powerful alternative to the traditional statement, offering more flexibility and expressiveness. Use collection functions to write concise code when working with lists, sets, and maps. Kotlin's collection functions provide a rich set of operations for filtering, mapping, and transforming collections in a functional style. Gradually refactor old code as you learn more about Kotlin's features and best practices. Refactoring is an ongoing process, and as you become more proficient in Kotlin, you'll be able to identify opportunities to improve your existing code. The more you use Kotlin, the more productive you'll become. Its concise syntax, powerful features, and focus on safety will help you write code faster and with fewer errors. Kotlin's design encourages safer, more maintainable code, leading to fewer bugs and easier collaboration. By adopting Kotlin's best practices, you can create code that is both robust and easy to understand. With the right approach, a little patience, and a willingness to learn, you'll quickly feel at home in the Kotlin ecosystem and wonder why you didn't switch sooner.